All right. How many of you have used Neo4j before? How many of you have used other graph databases? OK. Handful. All right, I got to get closer to the sensor here. But anyway, basically, we're going to give you an overview of Neo4j and graph databases, but in the context, obviously, of Russian Twitter troll data. Now, the data that we're going to be talking about here today is data that NBC News published. And Ben Popkin is the gentleman, the reporter at NBC that we're going to be talking about. And he calls it his love letter to democracy. Quote, "One important point has been universally acknowledged by the 9 previous reports about Benghazi. The attack was almost certainly preventable. Clinton was in charge of the State Department, and it failed to protect US personnel at an American consulate in Libya. If the GOP wants to raise that as a talking point against her, it is legitimate." And then our dear president talked about that at an event, at a rally in Pennsylvania, my home state. And as a result, it spread like wildfire all over the internet. So as we all know, I think at this point, there was a lot of news that wasn't quite legitimate that was published around the internet. The quote that I showed you was actually attributed by Trump and by other folks as coming from Blumenthal, which is Clinton's advisor. And it actually came from a Newsweek reporter. But that doesn't mean that Twitter and the internet and all sorts of other places on the internet talked about it as coming from Clinton's advisor. And so we saw how much, obviously, in the past election season, how much that a simple piece of news can get misattributed, misquoted, et cetera, and actually take over the conversation on the internet. And now, if we look at some of the other news, you see this tweet is unavailable. But this tweet that it's referring to was actually from a Russian Twitter troll. And the reason it's unavailable is because Twitter has deleted all of those accounts. But you can see that General Flynn here says, yep, this is a great ad. Now, first of all, he needs to learn how to spell a little bit. And he says it needs to be retweeted frequently. So General Flynn, who happens to have been the director of the Defense Intelligence Agency, manages to, we'll give him the benefit of the doubt, get trolled by a Russian troll, and is spreading that information. So even folks who have intelligence as their business manage to get fooled. So again, my name is Ryan Boyd, Developer Relations at Neo4j. There is my Twitter handle as well as my email address. Feel free to reach out to me if you have any follow-up questions. I am happy to try to answer them. I used to go skydiving. Now I have 2 children. Because of that, my partner does not let me go skydiving anymore. Just a little tidbit about me. All right, so this was a news article that was published by NBC, by Ben Popkin. Russian trolls went on attack during key election moments. And Ben actually talks a bit about how they used Neo4j and worked with our team on doing this analysis. Now, you're probably wondering, for those of you who aren't familiar with it, or with Neo4j or graph databases, but what is a graph database? And I'm going to use the tweets from my colleague Will to explain this. And so he did these back in the day when you only had 140 characters on Twitter. Do you guys remember that day? It was a while ago. So he tries to explain it in 140 characters. First of all, Neo4j is open source software. We are an enterprise business. We make money, but the core of our product is all open sourced, and you can access that source on GitHub. It stores and queries data. So Neo4j is meant to be a transactional database. The data is durable. We have ACID transaction support. The idea is a database much the same as you would use a SQL database or something like that for. And it can also do a lot of analysis and ad hoc analysis like you're going to see, and like you're going to see that Ben and NBC used it for. But at its core, it's a database. It stores the data as nodes and relationships. And this is a graph from the Neo4j browser. And this is a little bit small, but we have officers up here, intermediaries, entities. This is basically a graph of business relationships. And our nouns are nodes. Our relationships are the verbs. And then there's properties on the nodes and properties on the relationships, which are the adjectives and adverbs. Now, this is what we call a property graph, and we actually call it a labeled property graph because of the idea that each of these different nodes has a label or a type. So you could have a label that is a person, or a label that is an animal, or a label that is an officer or a company. The graph here is the data model from the Paradise Papers. The Paradise Papers we'll talk about a little bit more here shortly, but I'm going to give you some example queries with the Paradise Papers. So the next part of the definition is using the Cypher query language. This is Cypher. This is a query language. We think of Cypher as ASCII art for graphs. It's basically drawing patterns between bits of data. So in this case, we have a node that is an address, and we have another node that is an officer, and a third node which is an entity or a business. And what we're saying here is that an officer has a registered address named or called is an address node, and that officer has a relationship in somehow or the other to an entity or a business. So we're trying to say, find me all of the officers who have a registered address in Palo Alto. And we get back in the Neo4j browser a graph that looks something like this. Obviously, you can't read all of this. I will give you links later that you can use to try out this stuff on your own. But basically, this is showing here the officers and how they relate to businesses, and then how they relate to those addresses in Palo Alto. And notice this query, because of that sort of ASCII art, because of those arrows that are drawn here, you can actually read it without actually knowing Cypher. So you can say, officer has a registered address, officer is related to an entity. Now, Neo4j can return graphs, as you saw. It can return graphs, and you can then visualize those graphs. But more commonly, people actually use the graph database as a way to get higher performance. And we're going to talk about why that is. But more commonly, they're using it to get higher performance, and they actually return the results as a table. So in this case here, if we want to say, OK, we want to find the officers whose address contains Palo Alto, and we want to basically get a count of the jurisdictions, or the number of entities that they have in different jurisdictions in offshore bank accounts, we can do that and get tabular results. So you're getting the results in very much the same way as you would any other database. In fact, there's even a JDBC driver that you can use to connect to Neo4j to get the results in a tabular format here. So although you can use JDBC drivers, our most common way of being accessed is with client libraries or drivers in JavaScript, Java, Python, .NET. Those are the official ones. There's also ones in PHP and Ruby and a variety of other things contributed by the community. And these are all using the Bolt protocol, which is a binary protocol for accessing the data in Neo4j. Now, why a binary protocol? Originally, we had a HTTP-based protocol, that was used for Neo4j, and JSON is what got sent over the wire. Well, as many of you may know, JSON is not very type safe. In order to be able to express our type system in a way that was going to be translated back and forth in a serialization and deserialization process, we needed to use a binary protocol or have another way to encode that data. So we implemented a new protocol called Bolt, and you can see here how one might access Neo4j. This is using the JavaScript driver. And what we're doing here is basically at the top, just connecting to our own local machine, and then passing in credentials. You don't need to see that, although I will actually. That just sounded mythical. I don't actually have a real password here. It sounded like I was trying to avoid showing you my password. But anyway, and so this is the Cypher query. That's that query language that I was talking about earlier, and you saw examples. And Cypher, the Cypher query is just passed in here as a string, much the same as you would a SQL query. And in this case here, we're subscribing to the results, and on each individual record that is returned, doing something. And this is actually doing the results to show a heat map visualization that looks something like this. But so that was just JavaScript code that sat on the client side that returned data that is then presented in a heat map. So Cypher has been open sourced under the OpenCypher project and is used by folks like SAP HANA. And there's a more recent goal of actually taking all of the different declarative property graph languages that are out there and having a universal standard called GQL. This is something that was just been kind of championed starting this week. But OpenCypher is open. There are folks using it like SAP HANA. There are other applications that are using it. So Cypher for Apache Spark. If you have your graph data stored in Spark, you can actually write Cypher queries against it and get that graph data returned from Spark. One of the neat things here about Cypher for Apache Spark is the queries are composable, meaning that you can get a graph back, and then you can execute another Cypher query on the graph that was returned. All right, so I mentioned Neo4j is often used from a performance perspective. I would say when Neo4j first started, so it's actually been around since about the turn of the century. So it has been in development for about 18 years now. And our first commercial customers were, I think, like 6 or 8 years ago. And all of the customers initially were about performance. They wanted to find a faster way to access their data. Nowadays, you have more people that just like Cypher as a query language and think it's more usable. But initially, it was about performance. And it was about, in particular, about performance due to this property called index-free adjacency. Now, what that means is that if you are having two tables in a SQL database and you are trying to query across those two tables, you do a join operation. A join operation requires looking at an index. Index lookups aren't too bad if you're just joining 2 tables, 3 tables, maybe even 4 tables. As soon as you're joining 10, 15, 20, like a lot of the enterprises we work with, you start to hit what's called the join bomb problem. So you start to hit a performance bottleneck because of all of those index lookups. This is actually a slide or a picture that I found today from Dan McCreary. Dan is at Optum, which is United Healthcare. And I just taught a training class to him a couple weeks ago in Minneapolis. And then I found this blog post, and he did a really good, awesome job here. How to explain index-free adjacency to your manager. So a native graph database is you want to take a house and you want to find the house next door. Essentially, what we're doing is pointer arithmetic. We're basically saying advance 34 bytes in this file, and you have the house that's next door. It's a very simple operation, and that is what a native graph database does. Whereas in a SQL database, if you say, I have this house and I want to find the house next door, you go to an index, you look up the result, and you come back. And just the performance of that degrades as the size of the data increases and as those number of joins increase. Now, what does everyone think that graphs are good for? Well, there's a misconception out there that graphs are just good for Facebook or for Twitter or for social network applications. And sometimes it's really hard to get around that misconception because we actually have to use examples of social networks so that we can put everyone on a level playing field. So you notice earlier I'm talking about tweets. This whole talk is going to be about tweets. And so we do have these social networking examples, but graphs are actually used for anti-money laundering, urban planning, nuclear waste cleanup. This is about how you can use PageRank to filter out nuclear waste particles from water. And we have a variety of customers using us across recommendations, fraud detections, network and IT, master data management, knowledge access, a whole variety of different use cases. So graphs are useful anywhere where you care about those relationships between data. You care about the relationships as much, if not more, than you care about the data itself. So graphs are also good for data journalism. So what we're going to be talking about here comes under our Data Journalism Accelerator program. Basically what we say is, hey, if you're a data journalist out there and you have a set of data and you want to work with it in the form of a graph, we can do that, and we can help you along that process. And so we have engineers on our team that will work with journalists like we did with Ben. And the Panama Papers is probably the most famous version of that. So this was the International Consortium of Investigative Journalists, had 400 journalists around the world. They got a hold of a set of data, which was the relationship between officers and offshore bank accounts, and they published this set of data. And they had these 400 journalists, though, working on this data for a whole year in Neo4j, using also a visualization tool called Linkurious and a variety of other tools. They had all of this data, and then eventually, a year later, they published stories. Now, first of all, it's miraculous that 400 reporters around the world managed to keep something secret for a whole year. That's pretty awesome. And they also, by publishing this data, actually managed to get a variety of different political actors to leave their jobs. So the Prime Minister of Iceland, I think, and a variety of other folks were discovered in this data set. And for that, the ICIJ was awarded the Pulitzer Prize. And then Neo4j followed on and had a fellowship for journalists. And we sponsored Manuel here, who then went on to work on the Paradise Papers, which was just another data leak here. All right, so let's get to these trolls.
Question?
Yes?
For the Panama Papers and the others, were they using any kind of natural language toolkit, Stanford NLP or something?
So the question was, for the Panama Papers and the others, were they using any sort of natural language toolkit, Stanford NLP? Yes, I believe through other tools, but they were, they basically had a lot of the data as PDFs that they then OCR'd and took that OCR and did run NLP tools on it. For the data that went into Neo4j and was publicly released, that data originally was in a SQL database. And you know, one of the kind of sad things here is that they have a heck of a lot more data than you've ever seen. And they haven't been able to release it all simply because it's, you know, even with 400 journalists working on it, there's a core group at the ICIJ, and they're not big enough to look at all of the data. So anyway, donate to the ICIJ as a personal plea. And the ICIJ still has emails back and forth between all of the clients of this law firm and things like that. So there's a lot more yet to be discovered and that technology can help with. All of the Neo4j related work was basically one developer out of Spain that did this for the ICIJ. So Russian Twitter trolls, Internet Research Agency. So the Internet Research Agency is an organization in St. Petersburg, Russia. which is the organization which was creating a lot of these fake profiles and fake tweets. And the folks at Twitter were kind enough to release the list of suspected troll accounts to the Permanent Select Committee on Intelligence in the House. And there were 2,752 Twitter accounts that were tied to the Internet Research Agency. They were suspended by Twitter. And it says here, data deleted. There's some nuances here. But basically, as soon as Twitter suspended the accounts, those accounts were no longer accessible through the website and were also no longer accessible through the API. So the Intelligence Committee released this list, but we didn't have the underlying tweets. We didn't have the underlying accounts. We didn't know more information about these accounts and what they were tweeting about. And unfortunately, Twitter never actually released that themselves. So NBC wanted to learn more about what this data was, what these accounts were tweeting. And the first way that we worked with them in looking at, can we get the data from the web? So can we take the data via the Wayback API and retrieve, for instance, this 10GOP account and get the underlying data? So we did that for a number of accounts, and we were able to get them in from archive.org and basically get the data here as HTML, and even then convert that into JSON, which we then loaded into Neo4j. So we took that JSON data, which was each of the data, and I'm not going to go through this step by step, but it's actually quite simple. It's basically we're saying we're going to create a user. If it does not exist, create the tweet. If it does not exist, create the relationships between the user and the tweets, loop through the hashtags, loop through the links that are in the tweet, and put all of those into the graph. So we did that and formed a graph that looks like this. Sure.
Did you try working with Twitter and getting this data?
The question was, do we try working with Twitter and getting the data? No one at Neo4j did, as far as I'm aware, but this was a fairly known issue and fairly publicized issue that data wasn't available. And so I never saw Twitter, saying we'll release it, but we never directly tried working with them. Okay, so scraping the Internet Archive, loading the data into the graph, and the graph looks like something like this. So we have tweets. Those tweets can be possibly in reply to other tweets, and those tweets can be in reply to a particular user. Those tweet can mentions user. Those tweets are posted by, or a user posts a tweet. Tweets can have hashtags. Tweets can quote other tweets. Tweets can have media objects, photos, videos, etc. Tweets can have links. And tweets are posted via a particular source, which is things like the Twitter web client and other Twitter services. So the Internet Archive only had so many of these tweets. And so what then the folks at NBC stumbled upon is a number of folks who had been gathering the data on these tweets via the Twitter API during the election cycle. So well before this particular list was released, there were people that were gathering all the tweets related to the election and had a huge library of those tweets. So there were a total of 345,000 tweets with 41,000 users. And you saw like over 200,000 that we actually were able to process. But and this represents the 454 trolls. Now, Leroy loves USA. Notice that Leroy has his dog with him. And we have the Cleveland Online News. And we have the Tennessee GOP Party. And these are all Russian trolls. So obviously they took a way to say, how can we appeal to the American audience and let those Americans think that these are actual real things? And obviously, everyone knows that Americans love their dogs, so we have a dog. And these other accounts here basically just said, hey, we're the unofficial Twitter of the Tennessee Republican Party, or we pretended and masqueraded to be a individual news source. If you look at Leroy here in particular, you can see here we're saying we want to find a user whose screen name is Leroy Loves USA, who has posted a tweet that has a tag, thanks Obama. And you can see the graph of all those relationships. So we have Leroy Loves USA posted this tweet, which is, we hung out a huge banner right on the Arlington Memorial Bridge, which actually happened. Someone did hang a banner on the Arlington Memorial Bridge. It mentions Barack Obama and the tag, thanks Obama. And you can see posted by, has various links, or et cetera. So they took actual real events and magnified those real events with these troll accounts. And there is the actual banner for you and the underlying tweet. So when I say they took events and they magnified those events, this is the overall activity, the number of tweets that we have posted by these trolls on any given day of the year. And you can see some of the big actual events in the election cycle. These Twitter accounts were actually a lot more active during those events. The NBC folks also wanted to look at the hashtags that were used. In this case, we created a nice little visualization of it here. But let's just, I'm going to try to do this by holding like this. Let's hop over here. I'm going to go into my web browser and okay. Wow, I get someone to hold for me. This is awesome. Well, thank you. All right, so this is the Neo4j sandbox. So I'll talk to you a little bit how to get to it, but basically neo4j.com/sandbox. And you can create a Russian Twitter trolls sandbox. And what this means is that what you get is the data set as well as a guide that guides you through different types of queries that you can do. It introduces you to Cypher, the query language, et cetera, and then guides you through types of queries. And let's say that here that we wanted to find the hashtags that were used by Leroy here. So we're going to say user hope I got the capitalization right here, but we have Leroy Loves USA, and Leroy posts a tweet and has a hashtag. Let me just zoom in here for you guys. So my browser here is a little bit wide, but let's see here. I don't think I've ever had so much service while I'm giving a talk, so thank you.
Listen to that, future speakers.
So here I'm searching for Leroy's various hashtags that he used at his tweets and looking at fake news, snowflakes, nasty woman, and I'm going to order it by the most popular TCOT, which I actually have no idea what that is. Does anyone know what that means? Okay. MAGA, PGNet, Trump, Islam kills, etc. Variety of different, sometimes overly offensive hashtags. And really easy to write that query based off of that relationship pattern. Find a user whose screen name is Leroy Loves USA, that has a relationship to, like I could say posted, but I just left that out, a tweet with a tag, has tag, a hashtag, and that's what I'm doing here to get the aggregate hashtags that he used. Jump back over here. Thank you.
TCFT stands for Top Conservatives on Twitter.
Top conservatives on Twitter. Okay. Well, Leroy, the fake Russian troll, is a top conservative on Twitter, maybe. Is that a self-declared thing? But this is actually an important chart here. I was almost about ready to say graph, and that's the one thing if you work at Neo4j and you ever call a chart a graph, there's a lot of trouble. Seriously, my CEO has yelled at me too many times to count. But anyway, so we have this chart here, and it's about who the original offer is and how many times that the trolls replied to that. So you can see here, Real Donald Trump, Fox News, Jared Weiland, they actually used a number of the very well-known, popular, legitimate accounts and replied to those as a way to elevate their voice, as a way to make the, their replies more impactful because people were contributing to these streams of discussion on the tweets from Donald Trump, from Fox News, et cetera. And if you look at the individual troll accounts here, and we try to say, for each of those troll accounts, how many actual replies did they do? How many original content did they do? How many retweets did they do? You can actually see this is cut off a little bit. This is, the blue here is retweets. So, some of these accounts exclusively did retweets of other accounts. The orange here is original content. So others of the tweets or other of these accounts had some original content, but only a few of them had a lot of original content. And then red is the replies, I believe. Let me zoom out here. Yeah, so red is the replies here. So you can see here that these accounts actually took advantage of all of the other content that was out there and took advantage of the discussions that were occurring on legitimate accounts in order to share their message. You can also see the breakdown of the sources. What sort of clients are they using to post their tweets? And this actually, to me, I haven't looked at like Twitter overall, but I'm guessing Twitter overall has a lot of tweets from iPhone or Android. In the case of their tweets, they all came from the Twitter web client, or with a few more from the Twitter feed or TweetDeck, et cetera, but not nearly as many from the mobile apps. And that is because if you and I are doing jobs as creating these trolls, we're not going to be sitting there on our phones all day. Ideally, we'll use something a little bit more efficient, like an actual laptop or computer. And here we also looked at the links. We analyzed all the links that were mentioned in the tweets. As you saw earlier, we actually recorded the links in our graph. So we have a troll posted a tweet, which has a link with a URL. And then we looked at the domain name of those links. Now, we could have unfurled the URL shortener stuff. We probably should have done a little bit more analysis there. But you can see they actually did link to a lot of mainstream media accounts. So they didn't link exclusively to these random websites. They linked to a lot of mainstream accounts to build their credibility. Now, these are the tweets by hour of the day. And there is what is a work day. Turns out that tweeting on behalf of the Russian government to influence American elections is just another 9-to-5 job for a lot of people. All right, so that was kind of the initial analysis that we did on the graph and the relationship between things. I'm going to talk a little bit about natural language processing that we did. And yes, question?
What time zone is that? Is it
GMT? I was trying to do that math the same day. This particular slide is actually from a colleague, and I had the same question. and I'm going to figure out the answer, but I don't have the answer yet because he had marked this as being Moscow working hours, but Moscow working hours when this is 12 through 20 didn't quite add up. So anyway, if you figure out what time zone this is, let me know. Otherwise, I will look back at the source. But
Can you schedule tweets? Can you schedule tweets using tools? So which means that this may not matter, or
oh yeah, of course you can. The question is, can you schedule tweets using tools? Of course you can, but I have a feeling that a lot of this just wasn't that sophisticated. You just had a bunch of people who got hourly rates to sit there and create profiles, create tweets, etc. And yes, they could have used the APIs, they could have scheduled the tweets. Now, if they use the APIs, my guess is that that source would have automatically been indicating that they use the APIs. I'm not sure how Twitter's underlying infrastructure there is used. But I imagine that the idea that it came from the web client as the source, that's being recorded by Twitter themselves, not just the user agent that is making the request. In that case, then obviously, yeah, I mean, these people were just trying to pretend as much as possible to be like ordinary users of Twitter. All right, so there's a variety of different types of NLP operations you can do. What we were interested in here is looking at the organizations that were mentioned in the tweets, looking at locations and people and things like that, and trying to take what was our graph that looks like this, where we have Twitter tweets that have links, that have hashtags, that have users, and we're trying to turn that into a graph that looks like this, where we indicate that tweet mentions a particular entity, a person, or contains an entity, an organization, contains an entity, a location. And we used the GraphAware NLP library. GraphAware is a partner of Neo4j, and they built a library that uses a lot of the other underlying, like Stanford tools, et cetera, for the NLP. And that library is written in Java as user-defined functions and user-defined procedures. And so we took the data and parsed it through that. And here is an example here of how you might do that. So we find our tweets with English language, and we're calling this procedure, which is graphaware.nlp.annotate, passing in the text. And then the result comes back, and then we merge that annotated text onto the graph. So this is basically updating the graph to indicate the different results that come out of that GraphAware library. And here are the different things that were mentioned. So the left here is people, and this is in descending order, and we have Donald Trump at 5,600, Hillary Clinton at 4,800, Bill Clinton at 800, Mike Pence, Tim Kaine, et cetera. Locations, White House, New York, United States, Milwaukee. So basically a lot of things that you would expect, I guess, in the conversations around the elections. Now, what's in particular quite interesting, though, is a lot, or the majority of these things are election-related content, political-related content. If you looked at these accounts, they didn't tweet that much about their dogs or their family or their whatever else, although they used their pictures of their dogs. They tweeted almost exclusively about election-related content. And we built out a graph like this, and this is in a case of looking at find me a user who has posted a tweet which contains an entity mentioning Louisiana, and find the hashtags optionally, and optionally find the other entities that this contained. And you guys will all get these slides so you can follow up on some of these blog posts and look at this stuff in detail. But you can see how easy it is to write the query here of looking for all those other entities after you process them with the GraphAware NLP library. We also used algorithms. So one of the things that's unique about storing data as a graph is that you can use social network analysis or graph algorithms to do things like centrality, PageRank being the most common one, but also betweenness centrality, figure out the influencers, connectors in the network, closeness centrality, and a variety of other libraries that you can use, a variety of other algorithms that you can use on graphs that are sort of unique to graphs, including community detection. Now, use of algorithms to analyze this type of data actually really started with a gentleman named John Swain, who's British, and he was analyzing the Brexit tweets. And he actually used some other tools. He primarily used Gephi on the client side, which is commonly used by academics and such. But he used tools to look at the relationship between the influencers in the Leave campaign versus the Remain campaign, and wrote a lot of interesting things on it. But his pipeline looked like this. This pipeline is, they had the Twitter streaming API, collecting the data through Python, throwing them into a queue in RabbitMQ, sending the tweets into Mongo, and then from Mongo into Neo4j, and then from Neo4j into a variety of different R scripts, and then out from that into Gephi as visualization, or into MySQL, and then to Tableau. And oh my God, this is like just every technology under the sun put together in one pipeline. So they were actually really interested in seeing how they could lessen some of these. And they were interested in seeing how they could use just Neo4j for a lot of the graph algorithms components. And so we worked with them and built the initial version of our graph analytics library, and then have since rewritten a lot of it, but like the same core concepts of running these algorithms inside the graph as a procedure. And this is just in general with Neo4j. There are analytics integrations. We do have integrations into Spark and some other tools. There's the algorithms package I was just talking about here, Cypher you saw. And then APOC is a library that stands for Awesome Procedures on Cypher. Basically, it's 400 or 500 different functions that one of my colleagues wrote, which was his dream list of all of the things he wished the engineering team had implemented but didn't. He wrote them in this library, and it's all open source, and you can use them. But in terms of the algorithms, there's 3 different types of algorithms. Pathfinding, standard shortest path type stuff is built into Neo4j, but if you want to do some more weighted pathfinding, the centrality algorithms, and then the community detection clustering algorithms. All of these are basically callable from within Cypher as you write those procedures. You call an algorithm and you get the results. And I'll show you, for instance, one here. So this is talking about there's a stream variant and then there's a non-stream variant. The stream variant is basically get the results right back into get the results right back into be returned to you from Cypher. And then the non-stream variant is let's write those results back into the graph. So you can actually see here. All right, so here is me saying I'm going to call the stream variant, so I want to get the results passed right back to me. And these are all the different nodes that I want to run PageRank in this case on. So find me all of the trolls and return the IDs. And then I want to actually run this on an inferred graph. Basically what I'm saying is that if a user posted a tweet and then another user posted a tweet that retweeted that tweet, I want to infer that relationship, basically saying that if a user tweets or user retweets something, that they are amplifying that voice. And so I'm running the PageRank. It's an iterative algorithm. We're only doing 5 iterations here for an example. But basically what we're trying to figure out here is who are the most influential nodes in the graph, who are the most influential trolls in terms of then their tweets being retweeted by others that are in the graph. And you can see here, basically, I got the results back, but then what I wanted to do is just give me the top 10 nodes here. And the top 10 nodes looks like this. Let's see if I can. All right, so here's the top 10 nodes, and if I click on the labels up here, I can actually increase the size, or change the colors, as well as change the size here of the overall node. But we can see here, we have Dana Gizas, we have the founding something, Giselle Evans. 10GOP is actually the #1 influencing tweet, this Tennessee Party GOP, #1 influencing troll, I should say. And you can see here the actual underlying PageRank scores. If I return the table, the PageRank scores for 10GOP was 7.5. The next, and these are all just kind of relative, the next score was 4.16 with the Giselle Evans. So that 10GOP account, which was retweeted by Michael Flynn, formerly from the Defense Intelligence Agency, was the most popular Russian troll in this data set. So the last, when I just did that, you saw that I passed in this, this cipher projection, as we call it. Because oftentimes, basically, the data as you store it in the graph isn't the exact format that you want in order to do an analysis. So sometimes you want the data in a slightly different format, and that's why that you can pass in that cipher statement. So this is the one that we just did. We basically said, we have a user that posts a tweet that retweets another user. In that case, that first user amplified that second user, and that's where the PageRank passes. So similar, and basically similar to how you might think of a web page linking to another web page is amplifying that page. So this is kind of the overall architecture of how this graph algorithm works. So it loads the data in parallel from Neo4j. So Neo4j, for most types of data sets, the data is going to sit in memory in a cache. But the data structures aren't necessarily the most efficient for running a lot of these algorithms. So we have some modified data structure for the algorithms. So we copy it in memory into this other data structure. We run the algorithm in parallel as much as possible, and then write back the results in parallel as much as possible. And this actually, this process managed to increase the performance a lot over many other algorithm implementations. So we've actually tested this versus like Spark and GraphX and such. And one of the things, I'm mentioning parallel here, but it's parallel on the same machine, parallel across the cores in the processor. But one of the things that we've noticed is a lot of people, like you saw John's earlier architecture, try to use parallel processing across many machines. Back when I worked at Google and worked on some Hadoop type stuff or MapReduce stuff, you found people using MapReduce or using Hadoop for things that would have been faster to be analyzed in an Excel spreadsheet. People were just like, oh, I have all the computing power. Let me use all this power. There's a lot of overhead in copying the data between machines and rejoining, reducing the results back to the result set. So our initial way that we proposed that everyone do graph algorithms was actually, and I gave a talk about this, was actually taking data out, throwing it into GraphX on Spark and pulling the results back, writing it back into the graph. But there's just so much overhead in copying that data out and bringing that data back that this turns out to be a lot more efficient. One of the greatest things with algorithms is being able to visualize the results. So this is an algorithm. This is a chart here. Sorry, this is a graph here. See, I'm mixing those up. This is a graph here of these troll accounts, and 10GOP is down here, where basically we're saying the size of the node is based off of the PageRank. We have a color based off of community detection. So these were the communities that were, the red community, the purple, the yellow community were frequently interacting with each other. And then the thickness on the relationships is the weight of how much they interacted with that other account. This is built on the neoviz.js library. After tonight, as well as after just watching the news, if you're totally sick of politics, you can get into some virtual politics here, and there's some examples here using Game of Thrones. So you can see the interaction between Game of Thrones rather than Russian Twitter trolls. But this library allows you to do what you just saw here in terms of controlling it on the size and the color for the communities, and the weight being the thickness of the lines, all in like 15 lines of code here. You're basically just passing in the different types of nodes that you want to graph out, and what it should look at for the properties around the color and the size, et cetera. And so this is a library called NeoViz, built by my colleague Will on top of viz.js, which is in turn built on top of D3. Many different layers here, but it simplifies things quite a bit. And kind of towards the end here, want to point out that on February 14th, NBC released these Russian Twitter trolls, and we launched the Neo4j sandbox that you saw. February 16th, Mueller indicted the Internet Research Agency and associated parties. Is there a relationship? I don't know. No, I'm not trying to claim that there actually is, but it was pretty exciting to see that right after this report was published, that the indictments were handed down. So some conclusions here of the analysis. They did do some automation, but one of the biggest things they're doing is amplifying with retweeting other data. Data availability, we were kind of surprised that the data was not actually publicly released as part of releasing the set of Twitter accounts. My guess is that it's just kind of embarrassing for people to point that out, how much the platform was used for these types of tweets. But your call to action here is to go to neo4jsandbox.com, and you can launch your own Russian Twitter trolls sandbox. And like I was mentioning, basically what you get here is a step-by-step guide. Just scroll down and show you this briefly. So you get a step-by-step guide that shows you here's the graph model for the Russian Twitter trolls, explains the model, tells you a little bit about Cypher for those of you who are new to it, and how you can query the graph using Cypher. But then it actually goes through step-by-step and gives you queries that you can just click on and see the results. In this case, this is that Leroy Loves USA Twitter data. There's a whole variety of different tweets that we didn't even cover here. Different queries that we didn't even cover here that you can step-by-step through. If you prefer instead to graph your own tweets, that also exists. If you sign into the Neo4j sandbox with your own Twitter account, you can get, and I just did this from Starbucks before I arrived, it'll explain how you can run analysis on your own tweets. And in this case here, I'm looking at the hashtags that I've used, which is mostly about graphs, a little AWS, Docker, Minneapolis, things like that. But this is basically just a graph of all of my tweets and the followers, et cetera, and it builds it for you dynamically. It's all free, blah, blah, blah. But so I encourage you to check that out, and you can learn a little bit more about how these graphs work. And then with that, I will take any additional questions. Yes, in the green shirt.
So, context aside, isn't this a great example of effective guerrilla marketing? And from the other perspective, what is it that you can take away from this to promote your own product?
So the question was, context aside, isn't this a great example of guerrilla marketing? And what is this that you can take away in order to promote your own? Yeah, I mean, I think that's fair. I think there's actually quite a bit of market that has been built up for that in terms of people buying fake followers that then retweet them and things like that. I'd prefer to stay legitimate. I want to know that the people that are following me are real people, but sure. I mean, they obviously showed us how much that fake accounts can do in terms of promoting the message. Blue shirt?
Yeah, you mentioned the account for Cleveland Online, which is a copycat. The actual real account there, a copycat, is online in Cleveland. Even if they didn't know that all the IP addresses for this were coming from Russia, how come they didn't notice there was a copycat? And does Twitter generally have any obligation to tell people that they think copycat?
So the question was that one of the example accounts from Russian Twitter trolls was Cleveland Online, which is a copycat of Online Cleveland, or maybe vice versa. But and how come they wouldn't notice that this was existing? I can't answer on behalf of Twitter on that one. I mean, I think that you can use a lot of information about these accounts and the relationship between each of these accounts to detect things. It probably just was a lack of interest in doing it, right? Their platform was being heavily used, was getting very popular. I'm sure their numbers boosted a lot during the election cycle. Why are they going to seek out this? But I mean, I can't answer on their behalf. Over there, I think you're, yeah, Hat.
Could you just give us a little bit more oomph in terms of allowing us to imagine when we should use Neo4j in a graph database? I appreciate the deep dive, but I'm still a little bit confused about when to pull the tool out.
Sure. So the question is, can you give us a little bit more insight into when to use Neo4j in a graph database? And basically, any time where you're trying to analyze data that has a lot of relationships between the data. If you're looking at data and let's say that you're running SQL queries on your data and you have 2, 3 joins, whatever, that's fine. It's tabular data, that's good. You can leave it in a SQL database. If you start to notice that you have 10, 15, 20 joins and you aren't getting the performance you're looking for, that's when graphs are very helpful. The other thing that I would look at is just when it's easier to express your queries in a language like Cypher versus a language like SQL. That's another reason that a lot of people end up using graphs. But it's really about the ease of use there around Cypher, the query language. It's around the performance of querying across relationships. And that it's also around kind of the flexibility. You can add and remove things from the graph on the fly. You're not creating a schema in advance and having to update that schema. It's what we call schema optional. So you can have some constraints and other things around your data, but overall, you're not having to make massive changes or schema migrations and things like that. It's pretty easy to refactor the graph as you have your query needs change. But those are kind of the reasons: the flexibility, performance, and the ease of use. You actually already had a question, so let me skip to this other gentleman first.
Quick question on the numbers that you had. 345,000 tweets, and you analyzed 41,000. And you had mentioned that a proportion of those were obtained by getting back to the question about the indictments that you're talking about, would you want this all to be sourced directly from Twitter? And the next question is, have you looked at subsets of those tweets that were directly sourced from Twitter to see that your conclusions are the same as the larger set that you've looked at?
So let me try to summarize. Basically, there were tweets that were taken and sourced, well, via archive.org, and there were tweets that were taken and sourced from other sources that had collected them from the Twitter API. And have you looked at to see if the tweets that were sourced, well, directly from Twitter, there weren't really many sourced by directly from Twitter because those were all deleted. So they were sourced by archive.org or via these third-party sources. The third-party sources were anonymous folks that gave the data to NBC. No, it hasn't come into question as to whether that data was valid or not, and it hasn't been, explicitly researched. NBC trusted these sources enough to go through with publishing the data, and I know that some of the people that were doing work for the House Committee on Intelligence also got the same data, and no one raised any red flags. But obviously, you have to trust a little bit in the reporting there as being valid, or at least of them verifying the source were credible. But there was no like comparison done like you asked though. Yep. Yes.
You use a citation graph where if you build a data set where of who's citing whom, so let's say the New York Times citing the BBC, citing somebody else, you build a massive data set of who's citing whom. Would that be something useful you can do with Neo4j on that kind of graph that can help people tell whether a site is credible itself or not?
Yeah, so the question is you build a graph of citations and of the relationships between different sources that are citing each other. Is that something useful in order to determine kind of the validity of any statements? We've done a little bit of research into that. If you look up Neo4j fake news project, we had a computer science intern do some research into how we can analyze for fake news. We haven't come to any conclusions. But I certainly welcome that. We do have a lot of people in the enterprise world referring to that as data lineage, a lot of people that do use it for that purpose, and even use it for, in financial services institutions and things like that to trace back statements. But so I can imagine that there's some utility there, but we haven't had people that looked at specific with this data set. Yes, Joe.
A key part of your talk is the title, that these are Russian trolls. What makes you sure that they're Russian and not Ukrainian or Turkish or Iranian?
So the question is, a key part of your talk says that these are Russian trolls. What makes us certain that they're Russian versus Ukrainian or other nationalities? We are taking this as the word from the House Select Committee on Intelligence list of accounts. So Twitter gave that list of accounts to them, and they released that list of accounts. We ourselves are not making any determination on that, but it's based off of what is released by the House Committee on Intelligence. So I would imagine that Twitter had a lot of data to work with in order to determine who was in that list and who wasn't, IP addresses and other things. It's my understanding that they didn't try to mask it that difficult to the folks at Twitter, or that well to the folks at Twitter, but I don't know all of the details about how Twitter determined that. All right, yes?
I observed that you had a plugin or some kind of thing where Cypher translates to Spark job. So when should one use that? Is it just for compute, or if you have large amounts of data that it doesn't fit in Neo4j DB?
Sure. So they had, the gentleman mentioned that he saw where Cypher was being used around a Spark job. When would that be used? So that was the Cypher on Apache Spark project. And I think the creation of that is largely around the idea of you already have data in a data lake on Spark and you want to run analysis using this query language that's an easier way to write graphy queries. So that's basically it, is if you have data already stored on Spark and you want to run an analysis. There's a lot of people who that fits. You don't want to have to pull it over into Neo4j and then run your queries. You want to be able to run it directly. Yes?
I'm just wondering, have you tried or are you aware of any effort to the other agents, maybe other country may doing something, maybe US agents doing something outside of US? So is there anything like I can study about that?
So the question was, am I aware of anyone that is doing this for other countries or even the USA doing it in other countries? I'm not personally aware of that. I think that would be really interesting data to look through, but I am not personally aware of that. Basically, we only see the things that the press comes to us. Like, we're not currently actively seeking this stuff. We're working under that Data Journalism Accelerator program, so if the press comes to us with data, we help them out. But I'm not aware of that currently. Red shirt? Yes, you.
Yes, so can this be used for following the banking transactions?
The question is, can this be used for?
Is it really useful for figuring out all kind of irregular?
So the question is, can this be used for banking transactions? We do have a lot of financial services companies that use Neo4j, things like anti-money laundering, things like looking at insider trading activity and communications between traders before and after large trades, and insurance fraud. We have some state governments that use it for like Medicare and Medicaid fraud. So yes, that's certainly something that graphs are used for. One of the screenshots of a paper that I showed there was actually on anti-money laundering from the Federal Reserve and how they use graph algorithms, and the paper was dated in the early 90s. So that these technologies are used for that, and it's only gotten a lot more efficient. At that time, they were doing it on a desktop app and only looking at all of the transactions reported to them above $10,000. Nowadays, I imagine that they have some more data to work with and larger tools. Yes?
Conceptually, for graph databases, the realization of the concept of the Markov chain just made real.
The question is, a graph databases a realization of the conception of a Markov chain? Does someone else want to answer that question?
They're not. A hidden Markov model would have probability state transitions. Right. So this doesn't have to have any probability state transitions. It's just a graph. Was that? You can compute it as an attribute. Right. So just like he had attributes, right. Retweeted. So you could have attributes of probability from like 5%, 10% up to 95%.
And you can build out a decision tree.
I would imagine so. It might not be the most efficient, but it's possible.
Any other questions? Yes?
There's nobody else.
There's no one else. It's you.
What's the product management approach to take a Neo4j with respect to industry verticals?
Sorry, what's the product what approach?
What's the product management approach you're taking at Neo4j with respect to different industry verticals? Like, do you focus on the media industry especially, or was it just a use case with NBC?
Sure. So the question is basically, what is the product management focus and the way that we kind of build our product at Neo4j, and whether there's focus on particular industries. From a engineering and product perspective, we do not build with focus to any particular industry or use case. We do have, solutions engineers and teams of people who take the technology and build that stuff around it. But the technology is designed as a general purpose ACID transactional database. And more, we're adding in the analytical capabilities. So nowadays that's referred to as HTAP, or hybrid transactional analytical processing. But the engineering team and product team don't focus on any particular use case. I think I can't think of anything use case specific that's within Neo4j. Certainly big customers come along and ask for particular features, and now and then we give in. But overall, it's built as a general purpose database. Yes?
I have a question about, have you ever, do you have use cases where your Neo4j can be used for unsupervised learning? I mean that by now you have shown us this query, but it's you wrote those query. Maybe there is a way to extract patterns from the graph that you build, especially related to the questions of the last query.
Like clustering.
Clustering is still sort of supervised per se, right? You're specifying the algorithm for how to do the clustering. It's not learning on itself, right?
No, clustering is unsupervised.
I'm asking about unsupervised.
So there are the standard graph algorithms that are there, but outside of that, I'm not aware of other things in terms of unsupervised learning. But it might just be I'm not classifying that as unsupervised learning in my head. It might be that it's out there, but definitely happy to chat later. Anything else?
How does Neo4j compare with Redis graph?
The question is, how does Neo4j compare with Redis graph? Redis graph actually uses Cypher, so compares in a similar fashion there. I don't know the underlying details of Redis graph and what their design philosophies are. Certainly from a commercial standpoint, we don't see it much where customers are kind of comparing Neo4j versus Redis. But I don't know the underlying reasons behind it, or how they design their graph. Sorry. Yes.
What is the largest data size or data set that you can store in Neo4j?
So the question is, what is the largest data size or data set that you can store in Neo4j? Basically depends on your disk and memory. We used to have a limit based off the size of the identifiers for nodes and relationships, which was 34 billion of each, and we've now removed that. You can use larger identifiers. So we've seen people do more than that. I would say sort of the max, 90th percentile, something like 95th percentile is in the tens of billions of nodes and relationships. And a lot of people get really good value in the hundreds of millions range. But it's going to depend on your use case. I think people come to us and say, I want to do IoT type things and all, and it's certainly a graph isn't designed primarily around write performance. So we certainly try to keep on improving write performance. But the way that you're able to take advantage of the index-free adjacency is essentially you're writing those relationships at write time so that it's faster at read time. And so the types of use cases that you're going to use Neo4j for are traditional sort of transactional cases like you would use a SQL database for. If you have millions of writes a second from a sensor or something like that, you're going to want to write those somewhere else. We do have people that use Neo4j for things like IoT, but they're taking Those core, basically using a polyglot environment, they're taking those streams of data, writing it somewhere else, maybe using Kafka or something like that to calculate and determine when there's anomalies, and sending those anomalies over to Neo4j, and then looking at those anomalies in the graph. But so yeah, I'd say any scenario where you have all sorts of connected data, if you have very large kind of streams of data at millions a second, look for a different type of data store. Anything else? All right, thank you very much.